never playing horseshoes with you.
This is not horseshoes.
This is horseshoes.
Gear shoes.
All right, welcome back, everybody. We've got our next team up here. It's Team 2337. They're the EngiNERDs from Grand Blanc, Michigan. Guys, welcome back to Check-In. Good to have you. Can you guys introduce yourselves?
My name's Clinton Bollinger. I'm one of the co-head mentors of Team 2337.
I'm Alexis. I'm co-team captain and operator interface student section leader.
I'm Gus. I'm head of communications and senior programmer on the team.
Cool. Well, guys, welcome back. Glad you're here. Glad you're not snowed in.
Yeah.
So let's get started. Let's talk about all this cool stuff. First off, are you guys excited that former Michigan State quarterback Tom Brady has won the Super Bowl yet again?
I think we were building robots during that time. So
Okay. All right. Fine. All right. So moving on to the real important stuff. Let's talk about your practice and competition robots. We saw some footage in there, a good amount of prototype footage from your gear placer, but we also look at some pretty good-looking black sheet metal, which I assume is from your competition robot. Why don't you tell us what the status is so far?
So yeah, the black finished robot you saw is going to be our competition bot. It's powder-coated, all nice. So right now, we have the chassis basically done. We got some of the electrical done on them. The other robot that you saw was our practice bot, which we're going to be using for coding purposes and such. So for the chassis-wise, it's done. We still haven't finished putting on the shooter for either of them, but we have put on the intake for one of them. So
you want to talk about the electrical that you did this week? So you helped with that.
Absolutely. So we have our whole practice bot. All the wiring is completed on it. We got some of our pneumatics on there, and we're able to move with a fully functional intake, able to drive around in intake balls. So that's a pretty big step for us. So now that we have this, we can work out any quirks that we find and keep moving on with our competition bot.
Very cool. So we saw. Oh, go ahead, Clinton.
I was going to say our method is usually we build everything on practice bot first. Once we know it's good, we then move on to making that same part for competition bot. So we kind of put all of our errors and mistakes into practice bot.
I see. Okay. So that's interesting because we actually had Team 319 earlier. They build two robots as well, but they tend to build them in parallel. What makes you guys want to put all of your effort into the practice robot, then after that's done, all your effort into the competition robot?
well, I mean, there's always mistakes that arise from just making different things like shooters and intake and.
So sometimes we call those lightning holes. When a hole is drilled in a wrong location, that goes on to practice bot, and the correct one goes on to competition. Also, we spend a lot more time on the electrical wiring to make sure it's very clean, and lots of zip ties holding all the wires in place. And then we also only powder coat the competition bot.
Okay, that makes a lot of sense. Cool. So we heard is picking up balls, scoring gears, in your competition robots, assembling to get toward that point once you're ready. How is hanging going?
So we have mechanisms already like headed out. And
they're actually machining right now. Yeah. Probably if you were to turn 180 degrees from where you are right now, you would see machining behind you of the climber mechanism. So the hope is by before the weekend is to actually have the climbing mechanism strapped onto the practice bot and actually climbing.
Nice. That'll be great. So then the last bit of your robot, which we haven't heard of, we heard a little bit about it from you guys, is the shooter. So I think that's probably where a lot of teams are spending a lot of their resources this year because it's probably the most time-consuming challenge. Where are you guys along with that? How is things going? When do you think you guys are going to get it ready to put onto a robot and play with?
So I'll touch on this point. So we spent the last 3 to 3.5 weeks working on prototypes for shooter and the fuel tank for our robot where all the fuel goes. We decided this weekend to take a pause on that, figure out finish up for production, the gear mechanism, the climber, intake, all that's gonna kind of go around all of our shooter and hopper mechanism.
Okay.
So we kind of like paused on it. We spent a lot of time developing it, and we have it all in CAD, and it's actually ready to machine. But we don't want to machine it until we kind of see if any of the hanging mechanism or gear mechanisms are going to interfere, and we got to make a design or priority decision based on those mechanisms.
Okay, that makes a lot of sense. That's a good way to do it. Good to make sure that the most important part of your robot gets the most attention when it's needed, so it's not interfering with everything else. Very good.
And like I said, I mean, our feeling is, even though our number one priority for this year for us is shooting, the climber and gear mechanism cannot be ignored. Teams that do not have gear mechanisms and climbers, there's a chance that they might not actually make the eliminations. So we spent a lot of time on the shooter, a lot of time on the hopper, and we want to make sure that we're not going to fall into that where, hey, we don't have it because it doesn't fit because our shooter's there, and now we got to give up gears or give up climbing. We don't really want it.
No, I agree with that. So speaking about the shooter, I want to kind of touch on the control for the shooter a little bit. Last week, you guys mentioned that you guys were probably eschewing a PID loop instead of going with a bang-bang controller. I know that you guys said you have sort of pivoted away, but have you guys done any controls work on that or other stuff?
So again, we've been moving more towards our other mechanisms.
Yep.
So we kind of put that on hold right now.
Okay.
I would assume that by the end of this week, we'd be finishing that up, finding out which one works the best.
We're still testing both of them.
Yeah.
Oh, yeah.
I mean, we're not counting either one out. Whatever one gives us the best recovery time, that's the one we're going to go with. If it's bang bang, if it's PID, if it's some other EngiNERDs loop or something like that, we'll go with that.
Cool. All right. Sounds good to me. All right. So let's talk a little bit about your partner showcase. Can you tell me a little bit about what that is exactly and what it means for your team?
So every night on Bag Night, we started this in 2015. We invite all of our partners out, which they're basically our sponsors, but we believe in like a mutually beneficial relationship.
Mm-hmm.
So we invite them all out, and we invite like our school board members, and we give like a whole team design review. So we talk about what we've done for the whole season, and then we network with them and show them our robot for the first time. So they're able to ask questions and kind of experience what we do as a team. That way we're able to keep a close relationship with them. And what's really cool too is this year our superintendent's actually coming. So we'll be able to have our school board officials and like our partners.
That's awesome.
And we look at it as that they donate money and time and resources to us. The least thing we could do is pause on building our robot, even though it's the hardest time of the season of trying to get everything finished before we put it in the bag. We pause, let them kind of see and experience it. And then we've always typically had the owner of the facility we work out of actually signs off our robot during bag. So he's always the one to actually zip tie it and lock it in, kind of as a tradition.
Oh, that's very cool. And so this is planned for Bag Day in a couple of weeks?
Yeah, it is actually on Bag Day. So we will have to talk with check-in about how we're going to work it that night. So.
Sounds good to me. So I guess the question I have is superintendent of your school, that's actually kind of a really like big deal. That's a lot. There's a lot of kids in your school district, right? Like how many, like 10,000 more?
We have 3,000 people at our high school alone, so it's a very big school district.
Oh my goodness. Yeah. Okay. So
I think we're actually one of the biggest single campus school districts in the state of Michigan.
Wow. That's awesome. Well, congratulations to you guys. I hope your event goes well. I hope that the planning is going well. I guess the question is, it seems like you guys are real confident you're going to have everything ready for that day, right? You're going to have a great robot to show off to your sponsors and partners?
We must do a really good job up here of presenting that to you, yes.
Good. Excellent. Cool. All right, so let's talk a little bit about your plans before Bag Day, which is coming up in a week from Saturday. It's the Week 0 events. So they happen. A lot of them happen across the United States. The official one happens in New Hampshire, but a lot of local ones happen. And you guys are going to one in Michigan. Is that correct?
So actually, ours is actually a week 1.5. It's the weekend between Bag Day and week 1 actual events.
Oh, okay.
So we're actually going to be taking our practice spot there. Kettering University has a community center where they actually have a full field. They're inviting, I think it's a total of 24 teams out with 2 sessions. So each one has 12 teams. If you have a practice spot, or if you are actually competing in a week 1 event and want to use your unbagged time, because we are in the district model, I think the teams that decide to unbag and use that field, they actually have to give up 2 hours of their 6. So they are only going to get 4 hours. But this is also used to train volunteers, field techs, field reset people, FTAs, all that in Michigan, so that they can actually see how the field reacts and how accidentally triggering the hopper is going to affect field reset and slow the whole process down. So,
Cool.
So we're fortunate enough to have this in our backyard and be able to attend this. Like I said, we plan to actually take our practice spot there and hopefully get a better idea how this game's going to play before we go to our event, which is in week 2.
Nice. So this will be on an actual real field, like an official FRC field?
Ish.
Ish? Okay.
It's a Frankenstein. So my guess is we haven't got it confirmed from them. So they have the Andy Mark field at the center. So they already have that. So that is the real field. I do not know if they're going to have the air station and the gear mechanisms. I assume that they're going to have something extremely similar to that. Like I said, they try to do that so that the field crew that sets up the field can kind of have a test run.
Okay, so this isn't the FIM field necessarily, but it's a bunch of stuff that is close to it.
Ish.
Okay, ish.
Last year, to give the examples, last year they did something very similar to this. They actually brought the real defenses from the First of Michigan fields, but they kind of had makeshift towers and stuff like that. So, like I said, it's kind of a Frankenstein where things that have to be the real thing, they bring it. Things that can be wood, they use the wood one. Nice.
So, what are some things that you guys learned during these week 0 or week 1.5 events or 0.5 events? What are some of the things you're looking to test and practice or break on your robot?
Go ahead.
Well, I mean, Auton would be a great thing to test.
Oh yeah,
it's hard to get a feel for that.
Yep.
But also you got just how to run as a drive team too, just to get a general sense of how it's going to be, especially the view for this year with the 2 airships. It's gonna be hard to see. Yep. So yeah, it'll be hard. It'd be good to test that out.
Sightlines, I think, would be one of the biggest ones this season. I think of going to that week 0. We even go to week 1 events in Michigan, even though we're not competing. We go there just to scout and watch. See what the meta of the game is during week 1 to see if when we go to week 2 how that's going to play out.
Right, exactly. Yeah. And I mean, I was a coach for a few years as well, and you don't know how important it is sometimes just to practice just putting the robot on and off the field and who's got the cart and who's got the OI and make sure everybody's in the right spot.
We get extra person this year, so we're good.
Yeah.
There you go.
Right?
Perfect. We can have a 4-man lift on the robot, no problem. Or person, no man, but yes. So the last thing I want to talk to you guys about is the field elements. So you guys are. We see that you're in a different spot. You've got your
new location.
Yes, new location. You've landed the airship in your studio, it seems.
Ready to take flight or something like that. I don't know.
Yeah.
So we kind of show you kind of what we have going on behind us.
Yeah, we saw earlier that you guys were doing some gear flips, and it looks like your gear lifts are fairly accurate to the real things.
Yeah. So actually, we actually worked on this last few weeks. This is the design based on the field drawings. So we actually have, the rope and actually can lift the gear up just like the real thing. And just like the real thing, it could fall off if pilots aren't careful. Some interesting points that we actually have is that when the pilots are up here, we do actually have a piece of Lexan. You can kind of hard to see it here, but we do have the hole. So it is possible for the pilot to drop the cord outside, and they might not be able to do that anymore. Same thing goes with, there is nothing retaining the rope from actually going completely outside of the gear mechanism. That can happen. Yep. And the last thing that we kind of noticed is that when you tip this down, there's actually nothing retaining this from actually coming out of there either. So this whole mechanism could possibly, if it happens at an event, I'd like to see a picture of it where the whole mechanism could end up on the floor, and you're really out of luck, right?
So that's why they got 3 lifts, I assume, right? So you can, ditch one of them if you have to.
Yeah. We built all 3 so that we can have our pilot practice lifting the different locations and for the driver to kind of see the different angles for doing that. But
you guys started practicing already, or?
We've just did a couple tests. We don't actually have our full drive team picked out yet, but you can kind of see over here on this one. If you actually have it on the end of the rope, you can actually pick it up and bring it back in. But if you do have it on the end of the rope, you want to put that on there. You're really good at doing that.
Yeah, we saw in the video. Great tricks, by the way, man. Well done.
So if you actually accelerate fairly fast, it does come off.
Oh wow. Okay, that's good to know.
The other thing is if it's all the way back on the back side, you can actually pull up fairly quickly. I'm kind of blocking the view, I think, but it does hold on. So
okay, that's good to hear. Very cool.
And then I don't know if we're gonna swing over to the side here, and Josh can probably talk about. We have full-blown hopper with the trigger mechanism.
Oh wow.
So yeah, okay, we built the hopper out of the steel parts here instead of the wooden one they give you.
Yep.
And there are some things that we realized, like the trigger points on it. Obviously if you're pushing at the top, it's going to be easier to trigger than down at the bottom. But at the bottom is where the Lexan plate is, so there could be a team, with the bumpers restricting you. It may actually be hard to hit this top part where it requires less force.
Yep, that's true.
And then also,
Yeah, go ahead.
So when you trigger it,
Nice.
the hopper still sticks out past the wall. So that's another thing to note there.
Oh, so you can't slide across the wall flat.
Yeah.
You just have to be aware of it. The last thing is a lot of teams, what they're doing, I think, when they're doing prototypes, is if this is their robot, a lot of teams are going right up against it.
Yep.
Reset it. And we move it about, 3 inches, the space of a bumper, and kind of pull it back. And actually, if the robot was up a little higher, hold that back there. If we kind of trigger it.
Uh-oh.
If people aren't taking their bumpers into consideration, there's a chance that they could miss a lot of the hopper load. So I don't know if anyone has any questions about what we have here.
Yeah, well, everybody at home, make sure you check with your real robot. Never hurts to put a real set of bumpers on there, even if it's just as a spacer almost. It's always good to double check all that stuff. So that's great. That's great to hear from you guys. So I think that that's going to be just about it for us for the EngiNERDs for this week. Thank you guys for coming on once again, and thank you all for doing this and showing us your feel. It's a lot of fun. Up next, it's Team 3847, Team Spectrum. They're from Houston. We're going to have them on in just a second, but one more time, thank you so much to the EngiNERDs for letting us into your shop. It was a lot of fun to see all the cool field parts you've built. So we'll see you guys next week, but bye-bye for now.
Thanks, guys. See ya.
Bye-bye. Thanks, guys.